Hi, my name's Elise and this is Chris and we're from the UQ Science Demo Troupe. We're going to show you a demonstration about heat transfer. Have you ever thought about why we use metal for pots and pans and not plastic?
I suppose because the plastic would melt.
Yeah, exactly. You could imagine putting something plastic on a stove and it would melt because the stove's really hot. But what happens when you put a pan on a stove without anything inside it?
That would also burn.
It also burns. In fact, I've done that a few too many times before.
So have I.
Yeah. What do you do to stop it from burning?
You would add typically water or some other liquid or other food in there.
Yeah, so as soon as you add anything to the pan, say water or food, it stops it from burning. And we're going to actually take that to the extreme today. We're going to heat some water up inside paper without the paper burning. Okay, so, and this is an experiment that you can try at home. We've just got some paper and some balloons, and just make sure you've got some eye protection. So I've got a paper box here that I've made out of origami, and I'm going to light the candle, and I'll get you to light yours too, Chris.
Yep. Okay.
Now, what do you think is going to happen when I put this paper box over the flame?
I think it will catch fire in 3 seconds.
3 seconds. All right.
1001, 1002, 1003.
Smoking. Ah, yeah, that's definitely on fire.
Yeah, 3 seconds.
Okay. Now what I'm going to do is I'm going to put some water inside the box. Now the paper's going to get a little bit wet, but it shouldn't drip through. These boxes are pretty sturdy. So I've got some water inside this box, and now we're going to try and burn the box with the water inside.
1001, 1002, 1003, 1004, 1005, 1006.
Still not on fire.
1007, 1008.
Yeah, there you go. So there's water inside the box and it stopped it from burning. Okay, what's a bit more fun than paper?
Balloons.
Balloons, okay, good idea. So we've got a big balloon here for us to try. What do you think is going to happen if you put the balloon over the flame?
I think 3 seconds.
3 seconds?
Yes.
All right, let's give it a go.
Okay, here we go. 1001.
Yeah, instantly popped. Instantly popped.
Second.
So we've all been around candles a lot. If you put your hand above the candle, it's really, really hot.
Yeah.
So if you put paper on it without water inside, it's going to burn instantly. If you put a balloon, it's actually made of quite thin rubber, so it's going to burn through the rubber really quickly and pop the balloon.
That's right.
Now, you've guessed it, we're going to put water inside a balloon.
Oh, gotta see this one.
It's just got some food colouring in it so you can see it. I'll give that to you.
Yeah.
Okay, how long do you think it's going to take before it pops?
Oh, I reckon this one this one will definitely be 3 seconds.
3 seconds? Okay.
Yep. So here we go. 1001, 1002, 1003, 1005, 1006.
Yeah, so as you can see,
1007.
the balloon is not popping. Now what happens with water is that it's very good at absorbing heat and it takes a long time to do so. So if you heat water for a certain amount of time, it's going to take longer for that water to heat up than, say, something metal or oil, for instance. And this property that I'm talking about is called heat capacity. And something with a high heat capacity takes a lot of heat energy to raise its temperature. And this is one of the reasons that we like using water, because it has a high heat capacity. And things with high heat capacities take a long time to heat up, but also a long time to cool down. So they hold heat really well. Thanks, Chris.
Thank you, Elise.